Well, it looks like the electric outboard motor market has arrived. There are just literally dozens of brands now, and they offer a whole variety of models with a bunch of new features and brand new specifications that aren't too familiar with us. Now, to help us understand this new world of ePropulsion and all the things that it encompasses, we meet up with Joe Grez. He is the founder of EPCarry, has had years of experience in this whole electric marketplace, and he gave a live seminar at the Seattle Boat Show where he answered the question, is an electric outboard motor for me? This comprehensive explanation of electric outboard motors is all you need. So here we go. Welcome, Joe, to the Green Boater Podcast.
All right. So I am Joe Grez. What I do is I manufacture ultra portable motors for dinghies. And I've been doing this since 2009. I've learned a lot about the industry and a lot about the technology, what matters in different applications, grading systems, all this kind of stuff. And I want to share a lot of that with you. My background is physics and music and art. And I've been doing product development in my career, which involves toothbrushes with Sonicare, beauty devices for L'Oreal, solar panels in Princeton, New Jersey when I first started out my career. I've worked in countermeasures for military aircraft for a short time. I've also worked in toys and games and medical devices, broad range of different kinds of devices and technologies. 2009, we converted our boat to electric. Being a product developer, I instantly wanted to share it with the world. And it's taken a long time to figure out how to do that. But in 2017, we launched EPCarry. And over the process of learning the whole ins and outs of the electric outboard motor business, the things that I learned through that process, I'd like to share today. What we're going to do today is we're going to start with use case. All right, so that's product development speak for how you use it, what your conditions of use are, all that kind of stuff. We'll go through it. You will want to know what the ratings are for the options that you have to choose from, and you want to know how to read those. This can get complicated. I have 3 graphs, just to warn you. Okay, graphs are nice pictures, so you'll suffer through the graphs, but hopefully you pick up the difference between horsepower and watts and all those kinds of things that they rate these with. Motor types, there are 3 motor types that I'm going to review. General costs, what segments of outboard motors are kind of reasonable for consumers to purchase now, and we're going to give you a good return on investment, and which are not quite there yet. And then longevity, so how do you take care of them, how long they expected to last, what's going to go bad on them, that kind of thing. So when I go through the listing, I'm going to go through these parameters brand. So you have EPCarry is our brand, for example. The website, so you have a link so you can go and find out more about them, what models they sell, what are the ratings systems that they use. Okay, so some are going to use horsepower, some are going to use equivalent horsepower, etc. And then the general cost of the product that they're selling, how batteries are included in the system or not included in the system, what kind of batteries are required, manufacturing origin, right? Are they made in China? Are they made in Europe, made in the United States, kind of thing? Are they available or are they promised, right? A lot of, especially the large outboard motor companies right now, are just getting started. So they're accepting down payments for reservations, that kind of thing. So they're not shipping yet. Others are already shipping. And then boat type. So is it for a dinghy? Is it for a speedboat? Is it for a bass boat? Is it for sailboat, whatever? And then rather than going through this right now, I have another slide for that. So let's talk about use case a little bit. I'm going to start out kind of on the back end of it with recharging. Okay, so if your application is for day use or something like that, and it's a trailable boat, you have a lot of options, right? So you can charge your battery at home. You can charge it at a dock. You could use solar. You could use all kinds of different things, wind. If you have a boat that's always in the water, then you can't do it at home, right? So you have all these things to consider. Solar and wind. I have a lot of experience with solar, not so much with wind. Up on Lopez Island, I've got a 26-foot sailboat. Another person has a mothership, or a sister ship, I think. And they have converted their 26-foot sailboat to electric auxiliary. They're using a torpedo. I think it's 5 kilowatt or 6 kilowatt. And he is providing all of his power. He keeps it on buoy, so it's not hooked up to the dock. And so he has solar panels on it, and he used to have a wind generator on it as well. And so he would do, long weekend, maybe week-long cruises with this thing, and he would generate all of his own electricity as he went. I noticed it doesn't have a windmill on it anymore. So he's expanded the solar, so it looks like he's moved towards solar. I'm not sure why wind hasn't taken off, but it's something that you want to look into, especially if you're, doing a remote thing with high power. And if you're in an area where there's wind, which is important. But solar is a really good bet. I have a solar boat, has 300 watts of solar on the roof, and I can do 35 nautical miles in a day, day after day after day after day with that boat. In the summertime, not this time of year, but the days are getting longer. We're kind of accustomed to gas motors, and gas and diesel, that kind of stuff is pretty generally available. It's had the whole supply chain for that stuff's had 100 years to develop, right? And it's not quite the same with electric, but the good news is, company Pure Watercraft, they started here on Lake Union, makes 20 to 50 horsepower-ish kind of electric outboard, their own battery system, and they realize that every dock has the same kind of power that's needed for an electric car charging, right? So it's 220, 40 amps. And so they design their system around that availability of electricity, which is a pretty good idea. So there's all kinds of stuff at the dock that's available that has real oomph to it. And then mothership charging. Okay, so if you're going to be charging from your cruising boat for your dinghy, for example, you want to make sure that the size of the motor that you choose for your dinghy doesn't overwhelm your house bank, right? You don't want to stress that. Sometimes that's stressed too much already. All right, range. So your boat could use a motor for its main propulsion source, like my solar boat, right? It uses an EPCarry for that. That's the only propulsion source. I do have a paddle aboard, but I don't like to use that. And that means that I have to have sufficient range for that kind of application. If you're using it as an auxiliary to a sailboat, right, then maybe you don't need to have the same range, but that's a tricky one because in the summertime, you're in the Pacific Northwest, we don't have really reliable winds, right? But the good news is you can make your own wind with an outboard. So there was somebody that stopped by the booth today. They had just gotten a 29-foot, kind of a 2 unstayed mast, wishbone mast, Sharpie kind of thing. And he's got a small electric outboard on the back. And, for traveling several miles in like a 4-knot wind, he was able to go like 6 knots. It means very little of the battery capacity that it had because the motor was actually creating wind for the sails, which was creating more propulsion through the sails. So that's a good idea.
Are you finding with most of these electric motors that that you really, most of them, we should run it like half power? Because we're going to full power, let's watch that.
So that's a great question. Electric is not like gas, right? You don't have to run it at any particular point.
Yeah.
Right. So you can run it full out. They're all designed to not overheat at full power. Yeah. So you can run them at full power, half power, whatever. Yeah. And we'll go a little bit into, how you determine what size of motor you need for your application. And that's going to help determine what level of power you're using while you're using it. Yeah. And then and if you're using it as an auxiliary, though, there's really 2 kinds, right? So there's the day sailing kind, in which case you need more power, perhaps, to get back fast when the wind dies, but you don't need that much battery capacity. But if you're using it for cruising, you may not need quite as much power, but you need a big battery or a big energy source, right, to go long distances, right? So things to consider there. There's special needs, especially for those of you that are interested in dinghy powering, is whether you're going to be beaching the boat. So is the motor easy to lift up? Is it something that enables you to beach at speed? Those kinds of things. Portability is really important to a lot of dinghy owners because the motor is not going to live on the dinghy all the time. So if you put on the takeoff, right? So it has to be very lightweight and easy to manage that way. And then some applications are going to be remotely steered or remotely controlled, right, through a steering wheel and a throttle. Others, it's just going to be a tiller, and you just run it like a standard small outboard. And then finally, you have to consider your water, tides, wind, waves, salt versus fresh, kind of obvious stuff there. And then the final thing that I probably wanted to start with, but it's a bigger subject, so I have it last, and it leads into the next slide, which is speeds. All right. Do you like my cartoons? So when you're talking about speeds, you have to understand that there are two different modes of operation for an electric outboard, okay? And it's the same electric outboard doesn't work for both, all right? So electric outboards are really concerned about efficiency. So you want to make sure that the outboard is geared towards the kind of use that I give it, okay? So if you're in a displacement situation, generally the prop has higher slip values. What do we mean by that? The prop is basically a screw. Picture a wood screw. You're turning it into a piece of wood. Every time you turn it one revolution, it moves one of the threads in, right? You turn it another time and goes another thread. And that's all a prop is. It's just a really short screw with a relatively high pitch. But it's not going through wood. It's going through something that moves, right? So with a wood screw going into wood, you're actually pulling your way into the wood. But in water, you can't push on a rope. It's kind of like that problem, right? You push on water, it just moves out of the way. So an airplane that uses, a jet drive or a propeller drive, or a boat that uses a propeller, or, even a rocket, they use something else that's called thrust. And thrust is based on this relationship, forces equal to mass times acceleration. And in this case, we're talking about this over time. So we got a mass flow, gallons per minute, something like that, that's being actually accelerated towards the back, right? And as it does that, that reactive force moves your boat forward, okay? So it's not the same as clawing your way through the water. You're actually accelerating water. And when you're doing that, you're taking and accelerating all this water from in front of the prop to in back of the prop. But there's already water there, right? So now you're building pressure back here because you're trying to stuff more water into the space that already has water, right? That pressure doesn't move you forward. All that pressure does is makes part of it turn a prop. So if you have a little tiny prop and you're moving that water really fast, you're creating a very high pressure zone back there, and you have a very low efficiency of the prop system, okay? If you go with a very large disc area, right, you're going to have a very low pressure difference, and your efficiency of the system is going to be greater. So that's really important in a displacement application. The efficient motors that are used for displacement applications generally have a ridiculously large prop. Our outboard motor should have brought one, is for dinghies, yet it has a 13-inch diameter prop, okay? And I would have gone with 24 if I thought I could stomach it, but I can't. But it's not the same for planing, right? As a matter of fact, by the time you get up to 40 knots or so, a jet drive is actually more efficient than a propeller drive. And that's because of all the friction of the propeller going through the water versus a jet drive. So the diameter gets smaller and smaller as you go into higher speeds, okay? So big diameter propeller for slow speeds. And that's why the use case is so important, right? So how fast are you going to go? What's your expectation, right? If you want something that's going to race, hydro up on Lake Union or Lake Washington, something like that, not Lake Union, you're not allowed to go past there. Then chances are you're going to end up with something with a very small prop, right? But if you have a tugboat, you need a big prop. Same power, it's just a different kind of use case. Make sense? All right, so on our website, EPCarry.com, we have a product page, and on that product page, we have a bunch of resources, okay? And these are general resources, ones that are served with general, they're not brand specific, okay? So we're talking about battery options, we're talking about charging options, performance comparisons, history, electrical concepts, and now we're going to talk about ratings, okay? So everything I'm presenting is on our website on that ratings tab, okay? So if you miss something, you can go back and review it. All right, so physics. The performance of this boat can be completely described with two of these parameters down here. You need to have speed, and then you can have drag or thrust, right? One of those and speed is sufficient to fully describe the performance of a propulsion system on a boat, okay? Yet, all of the ratings that we use have nothing to do with those things, okay? So this is kind of a difficult situation. So historically, we're using, has anybody ever had a horse on their boat? Yeah, but we only use horsepower, right? And we know what horsepower means for a gas engine because we grew up with it, right? But when you're changing technologies or you're going from a highly optimized outboard motor where the prop is chosen properly for the boat versus not, right? Horsepower means less and less, okay? And when you're comparing electric to gas, horsepower is almost non-meaningful, right? And I'll explain why. Propulsive power is actually the one that is the most descriptive of these things over here, okay? Because propulsive power is equal to the product, and that's on the next slide, of drag times speed, or thrust times speed. And remember, thrust is equal to drag at a constant speed, right? So both of these are exactly the same thing, just opposite in sign. So one goes this way and one goes that way. And so propulsive power is actually a really good way to characterize the output of an outboard motor. Okay. Let's go into thrust and explain what's going on with thrust. Okay. We have the same little picture down here, right? Up here we have pounds, force, right? So this is the thrust like trolling motors would have. You know, you have a trolling motor on your boat. They're rated in pounds thrust, right? And then along here we have speed. Now, a 30-pound thrust trolling motor, how fast? No, I'm sorry. I have to explain this first. This blue solid line is the drag curve for 9-foot dinghy. Okay. This line is our EPCarry outboard. So you can see that it has a high level of thrust at very low speeds, right, compared to what's needed by the boat. And that's why it accelerates forward. And as it accelerates, the difference between what the motor is providing and what the boat needs is reducing. So the acceleration reduces until you get to this constant speed point. And then it's not going to go faster than that because what the motor is providing now is less than what the boat needs to go at that speed. Is that all clicking in? Okay. So a 30-pound thrust trolling motor, how fast do you think that boat will go? It's a trick question. If you're embarrassed with the wrong answer, don't answer. So this is the curve for a 30-pound thrust trolling motor, right there, this gray one. Everybody see that gray one? So a 30-pound thrust trolling motor is going to make this boat go about 3 knots because that's where the thrust curve crosses the drag curve of the boat. Now, what is that when it's rated at 30 pounds thrust? You know, why is it not producing the 30-pound speed over here of almost 6 knots? And the reason is the rating system is all messed up, okay? The rating system of a trolling motor is actually based on the input power. They've randomly chosen a 1/10 factor multiplied by the number of watts that the motor can absorb and called that the pound thrust rating, right? I don't know that that's the fact, but if you go through the different products that are online, that's the consistent thing, okay? 30-pound thrust trolling motor actually gives you 18 pounds thrust in a bollard pull, meaning that the boat's not moving, it's tied to a dock, right? And it can go faster than a little bit over 4 knots. This line over here is an 80-pound thrust trolling motor, which is equal to the EPCarry. But the 80-pound thrust trolling motor is drawing about 600 watts. And then a 110-pound thrust trolling motor, this is a canoe, right? This is like a 17-foot Grumman. The EPCarry will make this thing go, where are we at here? Yeah, so the EPCarry will make that canoe go this speed, and that's about equivalent to a 110-pound thrust trolling. So if I wanted to rate my EPCarry using the pound thrust moniker, right, what number would I use? Would I use the 110, the 80, or would I use the 30? The reason I bring up the 30 is because the 30-pound thrust trolling motor is using 300 watts and our EPCarry is using 220 watts. Pretty close, right? So if we were rating our EPCarry the same way as they rate trolling motors, we would say it's a 25-pound or 24-pound thrust trolling motor. But it's not. It's much more than that. So the rating system for thrust is not a very good way of rating things, okay? So be wary of products that are rated using the pound thrust argument and look for another way to understand it. So now we're going to talk about horsepower. This is the second of 3 graphs, all right? Once we're through these, we're done. This is the horsepower rating system. So what we have over here is speed of the motor string, RPM, okay? And on the vertical axis, we have two things. We have torque and we have horsepower. Now you got to remember that torque multiplied by RPM, remember this is RPM down here, right? So the torque, which is these dotted lines, multiplied by the RPM gives you the horsepower, and that's what these are calculated from. So the electric motor is here, this green dotted line, and you can see that its torque curve is pretty flat. As you load it down, it maintains its torque. But as a gas motor, as you load the gas motor down, you lose the torque, right? So we're accustomed to selecting a certain horsepower peak, the peak shaft horsepower that's rated a certain way. And we think we know what that means on a boat. But you can actually choose an electric that has a much lower peak horsepower rating in terms of peak shaft horsepower. And it'll do pretty much the same thing in a typical use zone. As a matter of fact, it'll be even better when the going gets rough. It's only in racing that you have to make sure that the peak shaft horsepower of an electric and a gas are the same. And the reason for that is, in these cases, you're optimizing everything for a specific speed, a specific kind of condition, right? So the industry has kind of determined that there is a multiplier between here and here that makes an electric equivalent to a gas, but it's a variable multiplier, right? So the EPCarry would use a multiplier of, if I remember correctly, it's like 4.5, right? So roughly 1/4 of or 4 times the peak power output of the EPCarry would be the rating equivalent horsepower. For Torpedo, it's around 2x. And for the Mercury, it's around 2.15x. So the take home from this curve, right, and this curve, this page over here, is that your motor, if it's going to be rated by equivalent horsepower, is kind of a hand wave, right? It's not an actual number like a measurement of horsepower would be, but even the measurement of horsepower isn't exactly indicative of the kind of performance that you would expect. All right, so it's all a guess. They have to trust your manufacturer. Questions? All right. Then input watts. Input watts is another one that's problematic. And I know this is good news, but like a Torpedo 603, it's called a 603 because 600 watts is its maximum input. Okay, and they have a 1003, that's 1,000 watts, and so forth. A lot of manufacturers use a number in the model name to denote the maximum power input, right? But look at this. So the EPCarry going 4 knots is drawing around 220, 240 watts, right? The Torpedo, to drive the same boat going the same speed, is using twice that light, right? So if we rated our EPCarry by its input watts, it would understate the performance of the EPCarry by 2x. So even the input power thing is not an easy thing to use, right? So notice where the trolling motor is over here. So the 30-pound thrust trolling motor can only, by the way, this is a 9-foot Minto dinghy. And these are actual measurements. So the trolling motor can just get up to 3 knots of full power, and it's using 220-ish watts. The Torpedo is using only about half of that. Well, a little bit more than half of that. And the EPCarry at 3 knots over here is using only about 70 watts. Okay. So the input wattage rating that you're going to see on these outboard motors is not necessarily indicative of the performance of that motor. Sorry to be the bearer of bad news. But what does work is speed, right? So if you have a specific boat and somebody does a test on that boat with a specific motor, with a specific, weighting and all that kind of stuff, and it goes a certain speed, then that's something that you can hang your hat on, right? So this is what we're doing, right? So we have this calculator on our website. You put in the boat length, you put in the boat type, you have 3 different boat types up there, and then you put in the weight. This is crew, boat, motor, everything, right? and it'll tell you what your full throttle speed is and your half throttle speed, and then the ranges for those using our standard battery. Okay. I have not thought of a better way to characterize a motor than speed on a specific boat, and it's complicated, but it's the only honest way to do it because all the rating systems don't work. Comments? Yeah, I often have customers come up to the booth or call me or email me, and they want to know what the thrust rating is or the horsepower rating, and I do make things up to try and make it easy for them, right? But when I start to explain how the rating systems are, I wouldn't say gamed, but they're not accurate. They're not really predictive. Then some people get angry. They don't like that because that's what we're all raised to expect, right? And who's this guy who's saying that they don't work? But in reality, they don't.
So where's the secret coming in for the EPCarry?
Why is it more efficient? Yeah. We cheated. Torpedo was one of the first people that, by the way, turn your cell phones off.
Yeah.
Yeah. And everybody else pretty much copied what they did, right? And what Torpedo did was they said, well, we want to get the biggest market swatch that we can, right? So we're going to design this thing for dinghies, but it's also going to be for 2,000-pound boats, right? And they optimized it so it would give the most impressive performance on a dinghy, right? Because all of the energy transfer and everything is optimized for the slower speed, higher thrust conditions that you'll have on that larger boat. Boats, right? So let's optimize this system just for smaller boats. And that's what we did. So if you go and, we chose the prop first because that's where most system, we ended up with a high aspect ratio, large disc area prop. And then you take that and you say, okay, well, that wants to go at this RPM when you reach hull speed on these boats, right? So that helps you choose the gear system to match those two, right? So you have everything operating at its most efficient point along the system. And then we chose to do a water lubricated lower unit, right? That doesn't require seals. With seals comes seal friction, right? Yeah. So it's kind of cheating. We're just a small boat builder. But no one else has done that.
So water lubricated, so it uses a water pump to...
It's just open.
An electric.
Just open. Yeah. So it's immersed in the water. So we have a brass pinion that drives, the ring gear is a Delrin material. And that's actually part of the prop module. So the drive shaft, that sticks out that the prop is on doesn't turn. So the bushings are in the prop, the plastic gear is in the prop, and then the prop's in the prop. So that's a replaceable item, and that's the part that wears. Yeah. And it's worked really well. It was a gutsy move from an engineering standpoint, but it's really proven out.
So if you kept the boat length and the weight's the same, you just changed the type, would type 3 go slower than type 1, or how does that?
Yes. Yeah. Good question. So let me just explain the types really quickly. So the type 1 is the most efficient.
Yeah.
So type 1 is like the Minto dinghy that I use for all my testing. Not all of it, but a lot of it. That boat has a very fine entry, fairly plumb bow, right? So its waterline is maximized. And the longer the waterline, the faster the boat. It also has a fairly narrow underwater section. And it has a full enough stern that it's not like sinking in the stern when you start to get up to speeds above hull speed, right? There are a lot of boats like that, PT11, stuff like that. This is a pram. The pram has a lot of rocker to it, right? And it's hydrodynamically very similar to a canoe or a kayak. It's pointy at both ends, right? Because most of the buoyancy is in the middle and very, very little is at the ends. And that is actually more efficient at slower speeds than the Type 1, but it's slower at around hull speed because it's creating a bigger wave that it can't climb. And then you got these guys over here, which would be somewhere in the neighborhood of type 1, type 2, except for they move the transom forward like up to 2 feet, right? Which is shortening the water line with respect to the length of the boat, right? And you can see that it's not going into the water until you're a foot abaft the bow. So the actual dynamic water length of an inflatable is generally like, 60% of the length of the boat. And that's why they don't track well. That's why they're hard to row. That's why they're slower with an outboard. The only situation where an inflatable is better than the others is in a planing situation where you have enough power that you get it up on plane. Does that make sense?
Yeah, thank you.
All right. So motor types. So we have elevated and we have pod, right? Everybody knows the pod motors. The trolling motor is a pod motor. The torpedo is a pod motor. ePropulsion is a pod motor, etc. Okay. And then you have the types where all the electronics in the motor are up here. You have a shaft that goes down with a double gear system down below. And 2 different types. They're further, this type is further separated into conversions and ones that are designed dedicated for electric use. Okay. And there is a difference mainly. That's why I mentioned prop size before. If it's a displacement application, then you probably want to go with one with a dedicated lower unit rather than one that's a converted gas, because the converted gas has a small prop. It's that simple. All right. So in the handout that I gave you guys, we have elevated purpose-built platforms, and in that category we have Ray Electric. Who knows Ray Electric? Awesome brand. Nobody knows about it. Morton Ray invented this motor in the 70s, right? And he started producing it in the 70s. And the motors that he produced in the 70s were sold mainly into like commercial applications, and they're still running. It's a bulletproof motor, and you'll see a picture of it. It's not very elegant looking, but it's super efficient. It's as efficient as the most efficient motors of today. His, I think, grandson is running the business now. Morton passed away a couple of years ago. But they're still producing them, and they're making some improvements to the platform and all that. It's fairly reasonably priced, and I think they go up to like 20, 25 horsepower. So it's a really interesting option for people that have those mid-size applications where they want a little bit more power, especially for a displacement boat, because it has this big working prop on it. Morton actually did his own castings. So the lower unit, he cast himself. The prop, he cast himself. They don't build them like that anymore. And then you have the elevated gas conversion platform motors, and there's a lot of those. Most notably, Elco. Elco has been around for 100 years, and recently, maybe 15 years ago or so, they started to produce a line of electric outboards instead of just inboard systems. And these electric outboards are basically using, standard gas outboards, and they're taking all the smelly bits off and putting electric bits on. Okay. I would use an Elco for a planing application. I would not use an Elco for a displacement application. But they do sell motors that are powerful enough to get a boat on plane. Okay, so it's a good option. And you have Stealth Electric, eVoid, Excel Power, Ilmore. I don't know much about Flux Marine. I talked to the CEO of Flux Marine. Nice guy. They're really focusing on commercial applications. It's a very nice solution that they have. And then you have the pod motor types. There's a bunch of those. Okay. Torpedo, you all know. Mercury's new to the game. Newport is a copy of Torpedo. ePropulsion is a copy of Torpedo. Pure Watercraft stands on its own, but it's still a pod motor. Carbon is a pretty rudimentary looking motor, but it's got quite a following in Europe. Harson, I believe, is a Far East brand. Octomot, and then Ring Drive Technology is an interesting one where they don't have like a pod. Even I had to put it somewhere, so that's where it is. The motor is a ring, and then the prop is inside of that ring. So you can find out about these brands in that handout. So cost, I work very hard to try and figure out what categories to put cost in and motor sizes in. Okay, I'm using horsepower, equivalent horsepower and horsepower here together. Okay, so that an electric, if it's an electric 50 horsepower, that's an equivalent horsepower. If it's a If it's a gas motor, it's just 50 horsepower, I'm betting. So this is kind of the range that seems to make sense, especially when you look at these things. So the initial cost of electric right now is about 2x gas, running around there. EPCarry is $2,000. A competing gas motor is around $1,000. Okay. But the cost over time is competitive for superior. And that is because there's like no maintenance, right? And you don't have to put gas in it, and you don't have filters to change, and you don't have, water pumps to change, and blah, 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 this stuff, right? So that you're using it over maybe 5 years or so, that would be your break even. And that's true all the way up to the 50 horsepower level, like pure watercraft, for example. This is really the best entry point, in my opinion, for boaters today, because the products that are in this category are more mature. They've been out for a longer period of time. They're more proven, and they're cheaper to get into, right? And nice. This is an interesting point. As a physicist, I did this calculation. Theoretically, a sub 6 horsepower outboard, so any outboard under 6 horsepower equivalent, right, can be cheaper, run for longer, and go faster than a gas outboard. So it's because of the weight of materials, the cost of materials, and the options that are available, and efficiency gains with electric versus gas. But above that, theoretically, it's impossible, right? So for the larger applications over 6 horsepower, even if you go 10 years down the road, electric's still going to be more expensive than gas, if you can get gas at all. Okay. Important point down below. You have a trade-off. I have a solar boat, Sunnyside, that I mentioned it can go like 35 nautical miles in a day, and it's using a little tiny 6-pound battery. I recently upgraded it to a 12-pound battery. But it has 300 watts of solar, right? Now, I can't go those 35 miles on the battery that I had there. If I wanted to go those 35 miles, I would have to get a larger battery. And that extra size in battery is more expensive than the cost of the solar panels on the roof. Okay. So especially you guys, in remote applications, kind of weigh the cost of solar panels versus battery size when you do your calculations. Okay. You want to make sure that you're not overspending on battery capacity. And you're using as much solar as you can in that application. And that's true for onboard solar mainly. Right. So larger motors, 75 and up, these are primarily for early adopters. So everybody know about, early adopters versus mainstream, this kind of whole continuum of consumer types. So, when Tesla first launched, they launched this Roadster, which was awesome. It was really fast and it ran for a long time, but it was not big enough for me to physically get into it, right? That was not sold to the mainstream. That was sold to the innovators, right? 3% of the American public, and that is the 3% that you hear about. These are the people with money. But they talked about it. And then Tesla launched the Model S, and the Model S had seats you could get into, but it still had that range and that performance, right? The cost was still high, so it didn't hit the mainstream. Mainstream needs the low cost, but it hit the early adopters that still had deep pockets and liked the technology and liked the opportunity. Then the early adopters talked about it, right? And then finally convinced the mainstream to start getting on, and that's what we have. The mainstream are starting to get into electric cars now, okay? Same thing is happening here. So the larger outboard sizes are in the early, I would say, early adopter phase, right? You still have a lot of, ultra rich that are buying electric systems right now because, well, they can. And then you have some of the early adopters, the early part of the early adopters that are buying these things now. The mainstream is far away, okay, because it's not practical for them from a cost standpoint. By the way, Tesla then went and launched their Model 3 and Model Y at similar prices to gas cars, okay? That's why they're entering the mainstream now. So that's not going to happen for these outboards until they can reach prices that are competitive with gas. Does that make sense? That's kind of where we are. It's the reality of the situation. The cost over time actually can pay back in commercial applications, right? So if you include the cost of fuel and maintenance and downtime and all that kind of stuff in a commercial setting, you can justify a lot of these high power electric outboards. Again, the tech will change and the costs will come down as the volumes increase. And this is true for both the smaller outboards and larger outboards, right? It's going to take time, but you can get oodles of price or of cost out of the manufacturing of these things with higher volumes. Right now, everything is still a boutique business. And again, costs can be reduced using solar instead of batteries, because batteries are one of the most expensive components. All right, where are we at for time? I guess about 5 minutes, right? So availability. So pretty much this is another kind of plus for the smaller motors. The smaller motors are generally available, right? Pure Watercraft now has motors that you can just go and buy, and they're in the 20 to 50 horsepower range. The Ray Electrics, they have them in stock, so you can order them and get them. EPCarry, Torpedo, ePropulsion, all these brands are just producing products that you can buy, right? But in the larger options, there's still a great number of them that are pre-launch. Okay, so keep an eye on them if you're interested, but they're not ready for main time yet. They're the big time yet. All right, let's talk about longevity. So I think it's really important for, if you're making an outboard motor purchase, you want to ask the manufacturer. Don't talk to the distributor. You know, the distributor may not have the information that you need. And when I say that, what I mean is they might not know and they might make something up, right? It's really natural for salespeople to do that. You want to talk to the manufacturer because this is a big investment, right? And the questions you want to ask are, is it supported, right? So if there's a problem down the road, you have a phone number you can call. Is there somebody you can get in touch? Are spare parts available, right? In the case of EPCarry, yeah, spare parts are available and you can repair it at home, right? Ask that of the other manufacturers as well, right? If you're interested in their products. And then look, does it seem well built? You can use your common sense here. Does it seem well built? Fit your application? This is kind of a big one that Torpedo was suffering with in the beginning. They suffered with scheduled inspections for their batteries and seals and stuff like that. And they also supported in country was a problem with the U.S. When they first launched, they didn't have any kind of network of repair facilities here in the U.S. And that was a problem, right? They've repaired that now. And I don't know if you've heard, has everybody heard that they were just acquired by Yamaha? Yeah, so we're going to see some changes come out from that. Now, in terms of inherent longevity, up here we've got, things that you're comparing against with gas, right? So you have to be careful of what kind of gas you get for your gas outboard. You've got filters to change, oil changes, the carburetor is going to get gummed up. So you're going to have to rebuild that thing. You've got the water pump that needs replacing for those that have water pumps. These are common in some electric and gas outboards, right? So some electrics have loop points and seals and an anode and a shear pin you have to worry about. EPCarry has none of those, but all electrics have a dedicated battery, connectors, and cables, right? So these are areas where you could have some issues, right? So make sure if you're going for an outboard that all this kind of stuff is covered by your manufacturer. They have cable options for you. They can replace yourself with connectors, and that the battery is something that's available in the future.
These waterproof then? The fully waterproof, the end?
Yeah, most of them are in the smaller size. Yeah, so, things that you're comparing against with gas, right? So you have to be careful of what kind of gas you get for your gas outboard. You've got filters to change, oil changes, the carburetor is going to get gummed up. So you're going to have to rebuild that thing. You've got the water pump that needs replacing for those that have water pumps. These are common in some electric and gas outboards, right? So some electrics have loop points and seals and an anode and a shear pin you have to worry about. EPCarry has none of those, but all electrics have a dedicated battery, connectors, and cables, right? So these are areas where you could have some issues, right? So make sure if you're going for an outboard that all this kind of stuff is covered by your manufacturer. They have cable options for you. They can replace yourself with connectors, and that the battery is something that's available in the future.
These waterproof then? The fully waterproof, the end?
Yeah, most of them are in the smaller size. Yeah, so I know that ePropulsion is, not ePropulsion, Pure Watercraft has done quite a bit of work to make their product waterproof. Of course, EPCarry is waterproof, Torqeedo is waterproof, ePropulsion. I don't know about some of the other brands, but a lot of these brands are copies of Torqeedo, so I'd be surprised if they didn't try and copy the waterproof aspect as well. All right, well, thank you very much. Thanks for showing up and asking good questions, and I'll be hanging out there after if you have any specific questions that you want to ask them. Private. Semi-private.
Thank you. Thank you.